So in this example, we have two rational expressions, and the task is to add them together. And of course, it goes without saying, simplify the answer as much as possible. The first rational expression is negative 5 over x minus 1. The second is 1 minus 3x over x. We just need to add these together and then to simplify the result. So anytime you're working with rational expressions, the strategy is going to be completely parallel to what you do with fractions. So if we know how to add fractions together, then we know how to add rational expressions together. And the biggest thing to remember when dealing with addition or subtraction of fractions or rational expressions is we always need a common denominator. Without a common denominator, any arithmetic that we do here is going to make no sense whatsoever. So our first task is going to be to get that common denominator. Once we have the common denominator, then we just have to add across the tops, add the numerators, and keep the denominator that we have. So let's look at an adding fractions example just to remind ourselves what this process looks like when we do it with numbers instead of expressions. If I'm going to add negative 3/5 plus 7/8, the first thing I might do is take that first fraction. The fraction itself is negative 3/5. And I'm going to rewrite it by giving that negative sign to one or the other of the numerator or the denominator. I think it's easier to give it to the numerator always when you have the choice. So instead of thinking of it as a negative fraction, we're going to think of it as a fraction whose numerator is negative. So I'm going to just promote that negative sign upstairs. So what I'm really adding is negative 3/5 plus 7/8. Okay, so now I just want a denominator that both of these fractions can agree upon. Otherwise, I can't add or subtract them from one another. So let's identify a common denominator. The quickest and dirtiest path to getting a common denominator is just to taking the two denominators that are there and multiplying them by one another. Here, 5 and 8, if we multiply them together, we get 40. This is not always the path that you have to take. You could try looking for the so-called least common multiple to try and get it into the simplest, the way that involves the least amount of effort. But this way will always work. Occasionally, it'll give you a little bit bigger numbers along the way to then simplify later on. But rather than have to fuss with least common denominators, I usually prefer to just multiply the denominators together. So in this example, that means we're looking for two fractions whose denominators are 40, which are equivalent to our originals, negative 3/5 and 7/8. How do we find them? Well, we just have to arrange the numerators of those fractions proportionally. And if we have multiplied the two denominators to get our common denominator, then to adjust the numerators, we can do this fabled process that all students try to do in inappropriate places, but which is actually useful here, that we call cross-multiplying. In other words, if I want to know how to turn negative 3/5 into a fraction with 40 in the denominator, because I have multiplied its denominator by 8, I need also to multiply its numerator by 8, negative 3 times 8. Likewise with the second fraction here, the second addend, 7/8. Because I have multiplied its denominator by 5 to go from 8 to 40, I need also to multiply its numerator by 5 to go to 7 times 5. I'm actually not going to simplify out those products just yet. I'm going to just leave them sitting there so that we can see where those numbers came from. This is the one place where I do advise using cross multiplication in the addition or subtraction of fractions. Okay, great. So now we have two fractions that have a common denominator, and we're trying to add them together. Now we can do that. We do it by adding across the numerators and by keeping the denominator as it is. So upstairs, we're going to get negative 3 times 8 plus 7 times 5. Downstairs, we still have that common denominator of 40. Never add those denominators. If I see an 80 down there, I'm going to immediately cross it out. Right? So the denominators are 40. The denominators remain the same, but we add across the numerators. Okay, great. Then what? Now is when we might look at that numerator and say, well, we can probably simplify that. Negative 3 times 8 plus 7 times 5. Let's multiply it out. Negative 3 times 8 is negative 24. 7 times 5 is 35. If I add those two things together, I'll get 11. So really, this fraction is 11 over 40. And the final question we ask ourselves is, can we simplify that? Is there a simpler way to write the fraction 11 out of 40? And so we'll try to look for factors that are common upstairs and downstairs by factoring everything in sight. Well, in this particular example, 11 happens to be prime. 40 is 2 times 2 times 2 times 5. And writing it out brutally like that shows us that there really is nothing in common. So we can't do any canceling in this particular example. If there were any common factors, we could cancel them. And then after canceling them, we would re-multiply back out everything that remained, and we'd get our final answer. So there's an example of how to add two fractions, right? Find a common denominator, and the quickest way to do it is just to multiply the denominators we started with. The other benefit to that is that we can then find the numerators that we need by cross-multiplying, multiplying the denominator of the second by the numerator of the first to get the numerator of the first fraction. And to get the numerator of the second fraction, multiply the numerator of the second by the denominator of the first. Then do the addition step. Add across the numerators, but keep your denominators. After multiplying out and simplifying what you have on top, that quotient can then be simplified by factoring everything in sight and canceling any factors that you see in common. Remultiplying back out anything that survives will simplify your final answer. So if we know how to add fractions, we know how to add rational expressions. Let's just do the same steps. So taking a look at our rational expressions, -5 over x minus 1 plus 1 minus 3x over x, we notice that that first fraction is written with a negative sign out in the front of it. So to make our lives easier, we're going to take that negative and promote it to the numerator instead. So we don't have to worry about it screwing up our answers later on down the line. So what we really have is -5 over x minus 1 added to 1 minus 3x over x. Now we need a common denominator for this pair of rational expressions. And the easiest way to find one is to multiply the denominator of the first by the denominator of the second. Be careful here to use parentheses because that first denominator has a couple different terms in it. It's a binomial, x minus 1. So a denominator that both of these rational expressions can agree upon is the product x times x minus 1, which please don't multiply that out yet. Multiplying out comes later. It's all the way down at step 4. We're still up here in step 1. Right? So our common denominator is x times x minus 1. So now it's our task to rewrite each of our fractions using that common denominator. How do we do that? Well, if we just write it as our denominator, we are then tasked with the process of figuring out what numerators we need. The first fraction, because it went from having a denominator of x minus 1 to having a denominator of x times x minus 1, in other words, because we multiplied its denominator by x, we also need to multiply its numerator by x. So again, we can think of it like a cross multiplication. The denominator of the second times the numerator of the first gives me the new numerator of the first, -5 times x. Likewise with the second fraction, because that fraction went from a denominator of x to a denominator of x times x minus 1, we've multiplied the denominator by x minus 1. We therefore also need to multiply the numerator by x minus 1, giving us a new numerator of 1 minus 3x quantity times x minus 1 quantity. And now our fractions have common denominators. So now it's time to add. Add directly across the numerator and keep the denominator that we have. So our denominator is still x times x minus 1. Our numerator is minus 5x plus the product 1 minus 3x times x minus 1. Great, so now our addition step is done. Now we just have a single rational expression and our task is to simplify it. We can do that by first simplifying out its numerator as completely as we can. So we're going to multiply out 1 minus 3x times x minus 1 by foiling, first outer, inner, last. It's going to give us minus 3x squared plus 4x minus 1. You can check that if you like. And then combining like terms upstairs, we have this minus 5x and this 4x that we can combine together. We'll get negative 3x squared minus x minus 1. So now my numerator is as simple as it's going to get. My denominator is, well, as simple as it's going to get. And now we need to know, is there any way to simplify the fraction itself any further? Are there any common factors upstairs and downstairs that may be canceled? Well, let's factor everything in sight. In the denominator, we've already have a complete factorization. There's nothing to do. Upstairs, can we factor negative 3x squared minus x minus 1? Well, let's start by bringing out the minus sign and thinking, can I factor 3x squared plus x plus 1? The only way we could try to factor that is by thinking about the trinomial factorization method that would have 3x plus something times x plus something. But those somethings that we try are going to have to be factors of 1, and there's only one possibility, plus 1 plus 1. And you try that, and you turn out not to get the right thing. You'd end up with minus 4x instead of minus x as your cross term. So you can beat your head against this all you like. There's no way to factor that numerator over the whole numbers. So we're kind of off the hook. It means we can just leave minus 3x squared minus x minus 1 as it is. Just like in the example we did with the fractions on the right, that 11 upstairs, there was nothing we could really do with that either, right? It just sort of stayed where it was. And so to finish simplifying, we're just going to remultiply back out that denominator. I saved that step for last because, until we're sure that nothing cancels, we should leave everything as factored as we can. But remultiplying it back out gives our final answer negative 3x squared minus x minus 1 over x squared minus x. So how do we add rational expressions? First of all, we need to know that we need a common denominator. So we find one. And the easiest way to do it is by multiplying the two denominators that you started with by one another. If you do that, you can find your new numerators by cross-multiplying. Numerator of the first times denominator of the second. That gives you the first numerator. And then numerator of the second times denominator of the first gives you the numerator of the second fraction. Then your fractions have the common denominators you need. So then it's time to add. Add directly across the numerators, leave the denominator the same. Then simplify what you have as much as you can, which in an addition or subtraction problem is always going to involve probably multiplying some stuff out upstairs and then adding or subtracting, combining like terms upstairs as much as you can. And then simplifying by seeing if there are any factors in common that we can cancel. So factoring everything in sight. In this example, that wasn't very interesting because there was no way to factor what we had upstairs. And therefore, there were no common factors that we could find to cancel upstairs and downstairs. If there were, we would do that. And then remultiplying back out the factors that survive give you the simplest form of the quotient.